Hello everyone, today we will learn about bevel cutting from start. First, let's introduce the basic concept of a bevel cutting. Bevel is the product of oblique cutting processing when the cutting head is in an inclined state. This process is what we call the deflection of the cutting head. The trajectory cut out at an angle is called the bevel toolpath. The blue areas are marked with the top and bottom surfaces of the sheet. FACut supports setting 7 basic types of bevels. The naming of bevel types is based on the shape of the English letters and the shape of the cutting surface. Such as V-bevel, it is a bevel generated by one cut, with the cutting head maintaining the same inclination angle. Y-bevel adds a straight cut based on the V-bevel, and the cutting surface looks like half of the letter Y. The X-bevel is 2 diagonal cuts in opposite directions, and its cross-sectional shape resembles half of the letter X. K-bevel is based on the X-bevel with an additional straight cut, and its cross-sectional shape resembles a part of the letter K. Fixed V-slope is a special V-bevel. The cutting head maintains a fixed inclination angle and controls the cutting through the XY axis to achieve a fixed angle between the upper surface and the lower surface. Gradient V-bevel is when cutting, the angle of the cutting head to material top surface getting bigger, so the bevel angle is getting bigger. Special shaped bevel is one surface of bevel is round, another surface is rectangle. What is outer toolpath and inner toolpath? Outer is you need the cutting fallen part as the final part. Inner is the part you need after cutting the rest of the material. Lead lines should be added on the material surface which you don't need. Deep gray part is the final part, shadow gray part is the part you want to remove. After setting the bevel, you could select and check the bevel properties. In FACut, the top view of the cutting pattern shows that the top surface and the bottom surface must not overlap. In software, the green line is the top surface. The highlight white line is the bottom surface. Using simulated to check, the red arrow will showing the direction which the cutting head inclines. Now let's see what a closed shape will showing in FACut. Take a circle as an example. The small green circle inside is the top surface, and the large white circle outside is the bottom surface. Also simulated to check the laser head incline angle. The inclination direction is from the top surface to the bottom surface. The top bevel is the bevel part forward direction to plate upward. Bottom bevel is the bevel forward direction to plate downward. Only V-bevel and Y-bevel have the difference. K-bevel and X-bevel have 2 bevel in different directions, so no top and bottom difference. Only bevel direction of parts you want as reference. These are both top bevels. Toolpath is the path cut by the cutting head. Flat cutting is one path, the straight cutting path. The upper limit of the beveled cutting path is 3. V-bevel is 1 paths, Y-bevel and X-bevel is 2 paths, K-bevel is 3 paths. Draw a line as example, now without bevel settings, it's a straight cut. After setting a top V-bevel, it will be marked as toolpath A and also the bevel type. Let's set a Y-bevel. You could see the straight cut path, toolpath B. Notice, bevel ABC not means the cutting sequence, it depending on the cutting head position and bevel position. Now it's cut B at first then A. X bevel is the same. You could simulate to check. Middle line is the original line position. K-bevel has 3 toolpaths, to slopes, 1 straight cut. Simulate to check cutting sequence. Notice, different toolpaths need to set different cutting settings for the same material. Beveled cutting and straight cutting settings is different, need to use color to distinguish. Also, different angles need different settings, so all toolpaths need to set cutting settings separately. What is the angle or width or height? Angle is the bevel inclination angle, that is, the angle between the cutting head and the material surface. Width is the beveled width, which is the distance between the beveled edge to the outermost edge. Notice, top width and bottom width may be different because you angle different. Some bevels don't have bottom width like Y bevels. Height bevel root gap is the blunt edge of the Y bevel and the K bevel. Because they have straight cutting toolpaths, so we'll have H height. The last basic attribute of the bevel is drawing size. For different bevels, the drawing size may be different. For instance, Y bevel drawing size is the straight cut toolpath distance. For X bevel is the two hypotenuses intersecting size. For K bevels it also the straight cutting path size. For V bevels, because the top surface and bottom surface sizes are different, so you could choose using big or small dimensions as reference. Draw a rectangle in FACut as instance, top V bevel, using small or big dimensions as reference. Drawing size same, but cutting result different.